through one of my exam questions from Chem 101. Okay, so this is a free response question from the third exam. So let's read this question. The price of propane C3H8 molecular weight 44.1 grams per mole is $20 for every 6.80 kilograms. The combustion of propane has an enthalpy change of negative 2,220 kilojoules per mole, meaning it's an exothermic reaction. As I've written here above, heat is a product. What is the cost of propane needed to heat 1 liter of water from 25 degrees Celsius to 90 degrees Celsius? Okay, so to begin this question, as you can see here, I have a couple of scribbles because what I recommend doing is when you see this complex problem and you're a little overwhelmed, just start doing something. That's what I started doing, and then I got on the right track eventually because I realized, wait, this is what I need to be doing in order to answer the question. So just start trying stuff. And then in that case, you'll have something written. So maybe you'll get partial credit, So here I started writing something and then I changed my tactic. So down here I did. So now I'm converting 1 liter and I'm ending up converting to grams because I want to use the Q equals MC change in temperature equation, which is on the equation sheet, because I see here that we want to find the heat or the amount of energy needed to heat this particular amount of water. So first, I'm going to find the heat or the energy needed to heat the water. So I'm using the Q equals mass times specific heat times change in temperature equation. So I have the 1,000 grams here that I converted. I just went from liters. 1 liter is a milliliter, and I found that using just a metric conversion. And then 1 milliliter is equal to 1 gram. And I canceled out these units by putting one on the top and on the bottom. So now I'm left with grams, 1,000 grams. So this amount of water is equal to 1,000 grams. So I'm plugging that in here. The reason we wanted grams is because this specific heat is joules over grams times Celsius. So in order for this all to cancel out in the end, and we're left with just joules, which is the amount of energy we want, this needs to cancel out. So grams and grams are going to cancel, and then Celsius and Celsius will cancel, leaving us with joules. So here we have 1,000 grams from our amount of water. Here we have the specific heat of water, which is found on the equation sheet. And then we have the change in temperature. So final minus initial, 90 degrees Celsius minus 25 degrees Celsius. So first I subtracted those two values of the temperature, getting 65, and I multiplied all of these three values together to get 271,960 joules. I divided that by 1,000 to get to kilojoules. I did that because up here we have our enthalpy value in kilojoules. So we need to convert something, so it's the same. So I just converted this one to get to kilojoules so that we can use this conversion factor of kilojoules per mole. So here we are. I took the heat down here is what we calculated. This is the heat needed or the energy needed to heat water, this amount of water. So 271.96 kilojoules. And then on the bottom here, I have our enthalpy of reaction to create just 1 mole of propane. So here's 1 mole of propane on top because it's 1 mole per 2,220 kilojoules. So now we're in moles of propane. So now what we can do is we can take the 1 mole of propane and equal it to propane's molecular weight, which is 44.1 grams. We find that through the periodic table, find this value. Then pretend like this is continuing over here, this part. I just ran out of room on the exam. So now I converted this up here. You can actually convert this in the dimensional analysis as well with just conversion factors, but I did it over here when I was thinking about the equation or the question. So I multiplied 6.80 kilograms by 1,000 to get to grams, which is again the metric conversion factor, going to kilos to grams, the standard unit. So now we have 6,800 grams of propane is $20. So now I'm going to take that value here and get us to dollars because that's what the question is asking. So we're in grams, now we're at 6,800 grams. of propane is equal to $20. Perfect. Now we're in dollars and we've combined everything we needed. We've combined the amount of heat needed for this water, we've combined the enthalpy of the equation, and then we've gotten to grams to dollars. So now that's going to leave you with 0.0158. I actually got this question a little bit wrong at the rounding. I should have rounded to 0.016 is the answer up here. That's because we needed 2 sig figs for this because of this temperature value. So I actually had 3 sig figs. And it's okay for this, in this case, to have 3 decimal places for money, because often gasoline has that extra decimal place, the 3rd decimal place for price of gasoline. So that's why that's okay, even though it's money in this case, to have 3 decimal places. So this is the final answer. Okay, now I'm going to stop share. Okay, that's all I have. Thank you so much.